Today's goal is to decide whether two quantities are in a proportion by testing equivalent ratios in a coordinate plane. So basically what that means is you're going to take the information from a table, we're going to put it in a graph, and we're going to find out if it is in proportion. If the information from the table, no matter what two sets of information that we get, that it's in proportion. So you can go ahead and pause and then copy down the graph and copy down the chart and then pick it back up when you're ready. I'm going to go ahead and start graphing the information. So first, this is comparing the cost of bananas per pound. So first, of course, is 0, 0. No bananas, no pounds, doesn't cost anything. Then we have 1 pound equals equals 25 cents. That's pretty cheap. I wish it was like that right now. So 1 pound is 25 cents. 2 pounds is at 50 cents. 3 pounds is at 75 cents. Make sure that you're going by twos. Okay. 4 pounds is at $1. 5 pounds is at $1.25. 6 pounds is at $1.50. Now, if you look closely, this is a pretty consistent, smooth line. That's actually a very good slope. It's a perfect slope. It starts at 0 and it's inconsistent. Anytime we would put a point on this line, we know that it would be in proportion. Now, to prove that it's in proportion, we just have to set up a proportion. We're not going to solve because we have all the information that we need. We're not looking for the amount or anything. If we were looking for the amount, for example, if it gave us the cost and it wanted to know how many pounds would that be, then yes, we would use X, cross multiply and divide to get X. But right now we're just proving it. So to prove it, we're just going to set up a proportion. And we're going to put, I'm just going to choose 1 pound is 25 cents. I'm still going to use the same concept, putting my dollars to dollars and my pounds to pounds, or vice versa, as long as you're consistent with it. As long as you're consistent. So my dollars, I have 25 cents gives us 1 pound. And then I'm going to pick, you could pick from any one of these. I'm going to pick 3 and 0.75. So 75 cents equals 3 pounds. So all we have to do is cross multiply. It's no division needed because we're just trying to figure out if they're in proportion. We're just proving it. So I'm going to cross multiply. 0.25 times 3 is 0.75. 0.75 times 1 is 0.75. Are they equal? Yes. So this graph, it is in proportion. Any data that you pick from the table is going to be in proportion. So that's basically what you're proving. Let's look at a different one. This is the cost of books. So it has the cost of books versus, the number of books versus the cost of the books. So we have 1 book equaling $3, 3 books equaling 9, 4 books equaling 12, 7 books equaling 18. It seems like it might be in proportion, but let's just look at the graph and see. So 1 book would equal 3. 3 books would equal 9. Seems like it's going okay so far. 4 books would equal 12. Make sure that's in the right spot. And 7 books would equal 18. So you're up here. So looking at the line, there is a small break in the line at different points. It does not go through consistently. So that automatically, just visually, it tells us it's not going to be in proportion. So to prove that, we set up a proportion. Alright, just like we would do normally. So we could do the number of books. I'm going to put books to books. And then dollars to dollars. Remember, you can, as long as you're consistent, you could put the money on top and books on the bottom, as long as you're consistent on both sides. So I'm going to do 1 and 3, the number of books to the cost. And then I'm going to put this 7 and 18 down there, because everything else, it seems like, yeah, we're pretty much in proportion. Because if you simplify 3 and 9, it's going to be 1/3. You simplify 4 and 12, it's going to be 1/3. However, 7 and 18, it's not going to work out. So if we cross multiply, 1 times 18 is 18. 7 times 3 is 21. Does 21 equal 18? No. So we put a line through that equal sign saying that that is not equal. Alright? So what you're doing is you are graphing and you're showing visually that it does not work. Then you're showing using a proportion that it does not work.